science friends. Today we are talking about mole ratios. So mole ratios are the ratios of the number of moles of a compound or a molecule in an equation. So for example, we have three different mole ratios here. So we could say there's one nitrogen for every, 3 hydrogen, okay? That's a mole ratio. We could say there's one nitrogen for every 2 NH3, okay? That's a mole ratio. And then we could also say there's 3 hydrogen for every 2 NH3. That's the third mole ratio, okay? All of these can also be flipped. It doesn't matter which one's on the top and which one's on the bottom when you do these. So what we have to do in stoichiometry is we often use mole ratios to do our dimensional analysis across the page. And so what determines which one you put on the top or which one you put on the bottom is based on what you have to cancel out from the step before. So if in the step before this I had H2, then I would want H2 to be on the bottom so I could cancel it out, okay? If I had N2 at the top of the step before, then I would want to reverse this and have N2 on the bottom so that I could cancel it out. So that's what you need to know about mole ratios. So let's take a look at this problem together. How many moles of ammonia are produced when 0.6 moles of nitrogen react with hydrogen? Okay, so this is our ammonia here. This is our product. How many moles are produced when 0.6 moles of nitrogen react with hydrogen? So we have to always start with what we're given. And so what we're given here is 0.6 moles of nitrogen. Okay, now remember, you don't write moles like a big M or a little m. Neither of those are correct. When you write moles, you want to write M-O-L, or you can write it all out as M-O-L-E-S. Okay, but that's your only abbreviation for moles is M-O-L. So start with what we know, 0.6 moles of nitrogen. And what we're trying to get is to the ammonia. So we have to set up a mole ratio. So if we look at our mole ratio, this equation's already balanced. And if you remember from yesterday, I told you you have to have a balanced equation to do stoichiometry with. Okay, so you always want to first check and see if your equation is balanced. But our mole ratio here is 1 nitrogen for every 2 moles of ammonia. Okay? And I put nitrogen on the bottom so I could be able to cross it out with the one before. So when I multiply this through, what I should get is 1.2 moles of NH3. Okay? And it's just really simple. 0.6 times 2 and then divide by 1 if we don't have anything to divide by really here this time. Okay? And that's moles of nitrogen. That's how many moles of ammonia are being produced, and that's what it asked us for. All right. Now, let's let you try this one, okay? I'm going to pause this and work it out. You pause it too, and we'll come back together in just a moment. So I didn't leave myself a lot of room here, but hopefully you can see it well enough. The first part, write the 3 mole ratios that can be derived from this equation. So you should have something like what I have written here. If yours are flipped, that's fine, but you should have 4 moles of aluminum per 3 moles of O2, 4 moles of aluminum per 2 moles of Al2O3, and 3 moles of oxygen per 2 moles of Al2O3. Okay, that should be your 3 ratios. In the next one, how many moles of aluminum are needed to form 3.7 moles of Al2O3? So we start with what we're given in the problem, 3.7 moles of Al2O3. We choose our mole ratio that takes us from Al2O3 to aluminum from the top, and then multiply through, and you should get 7.4 moles of aluminum. Okay? In the second one, basically you're doing the same, starting with what they've given you and trying to get from aluminum to oxygen. So you do the 3 to 4 ratio. So over here we flipped this ratio. to get what we needed where we needed it. And you should get 11.1 moles of O2. And then on the last one, if you start with what you're given, 0.78 moles of O2, use your mole ratio and set it up where you can cross out those units with the 2 to 3. So again, we swapped this mole ratio top to bottom to get how we needed it. And you should get 0.52 moles of Al2O3. Okay, so that you're doing stoichiometry here. Now, yes, it is going to get harder, but this is basic stoichiometry. Okay, so let's take a look at this one together. Calculate the number of grams of NH3 produced by the reaction of 5.4 grams of hydrogen. So again, we always want to start with what we know, with an excess of nitrogen. Okay, the balanced equation is shown here. So we're starting with 5.4 grams, and we are trying to calculate the number of grams of NH3 produced. Okay, so we know that in hydrogen, we have to go from grams to moles, and then from moles back to grams. Okay, we can't go straight from grams to grams of nitrogen. But we know the molar mass of hydrogen is 2 grams of hydrogen per 1 mole of hydrogen. Now we get that from the periodic table. Remember, H has a mass of 1, but we have H2 here. So that's going to have a mass of 2. But that's just for 1 mole. Okay? So that's how I got this conversion factor here. So we can cross out our grams. But now we have to get from moles of hydrogen to moles of NH3, okay? So we're going to say 3 moles of hydrogen is equal to 2 moles of NH3, okay? That allows us to cross our hydrogen out, and we are over here to NH3, which is what we're trying to get to, okay? Now, our question is really asking us about grams of NH3. So in 1 mole of NH3, if you add up those masses on the periodic table, you should get it to be 17 grams of NH3 in 1 mole, okay? Nitrogen is 14, and then hydrogen is 1 each, so that makes 17. So then if we multiply this across, again, we can cross out our moles here. That'll give us our answer in grams of NH3. So 5.4 times 2 times 17. I like to do the top first, and then divided by 2, divided by 3. And if I did my math correctly, you should get 30.6 grams of NH3. So let's take a look at this one here together. So we have another practice problem. Acetylene gas is produced by adding water to calcium carbide, and they've given us the equation. Now, this one appears to be a balanced equation. If you have coefficients in it, you can just probably assume that it's already balanced. It doesn't hurt to check it. But if you see a coefficient, they've probably already given you a balanced equation. If you don't see any coefficients, it may be balanced. It may just be that all of the coefficients balance at 1. But you definitely need to check it if you don't see any coefficients to make sure it's balanced before you begin. So this one's balanced. So let's go ahead and start with the second bullet here. How many grams of acetylene are produced by adding water to 5 grams of CaC2? So I'm going to start with what they've given me, 5 grams of CaC2. And I'm trying to find grams of acetylene, okay? Which our acetylene is the C2H2, okay? So we're going to have to go from grams to moles of calcium carbide, and then we're going to have to go from moles of calcium carbide to moles of acetylene, and then moles of acetylene to grams of acetylene. So this is several steps along the way, okay? So if you figure up the mass of calcium carbide, there are 64 grams of calcium carbide in 1 mole of calcium carbide, Okay, so calcium, remember, is 12, and there's 2 of those, so that makes 24. And then I think I said calcium, I meant carbon. Carbon's 12, and there's 2 of those, so that makes 24. And then calcium is like 40. Okay, so we got 64 grams of calcium carbide in 1 mole of calcium carbide. So that allows us to cross that out. Now we're going to need moles of calcium carbide on the bottom so we can get rid of it. And we're trying to get to our acetylene. So there's 1 mole of calcium carbide since our coefficient here is 1. And there's only 1 mole of acetylene. Okay, so our mole ratio there. All right, and that's going to allow us to cross this out. Now we're trying to get the mass. So 1 mole of C2H2. If you add that mass up, it's going to be 24 plus 2. So it's going to be 26 grams of C2H2. So we'll cross those out. It's always important to write this out. Some of you try to skip steps. Don't skip steps and cross it out. It just is, it's very easy to mess up, okay? Even for me, if you don't write it out and cross out the steps as you go through. So now what we need to do is multiply through and divide and see what we get. So I'm going to multiply the top first and then divide by the bottom. So 5 times 1, which we know that you don't really have to do that step. So 5 times 26 is 130, and then divided by 64. And that gives me 2.03 grams of C2H2. Okay, and that's how we would do this one. 2.03 grams C2H2. Okay, now using the same equation, determine, I'm going to have to erase this bottom part so I can have space, sorry. Determine how many moles of CaC2 are needed to react completely with 49 grams of water. So again, we start with what we know, 49 grams of water. Okay, we want to do our molar mass of water. So in 1 mole of water, there's 18 grams of water per 1 mole of water. Okay, that will allow us to cross that out. So we're going to put 1 mole of water on the bottom. Actually, we're going to put 2 moles of water on the bottom because the mole ratio with water is a 2. Okay, and we are trying to get to moles of CaC2. So our coefficient for CaC2 is 1. So 1 mole of CaC2. And the question is in moles of CaC2. So this time we're not having to go all the way to grams. So this one was just a little bit shorter. Okay, we can cross out our coefficients. So we're going to do 49 divided by 18 and then divided by 2. So that should give us 1.36 moles CaC2 for that one. Okay, and that's how we do that. We're going to skip the demo because we're not going to do the demo. If we were in class, we would do the demo. So you all have an assignment today where you have to practice these. You have stoichiometry worksheet 1. Oh, I'm sorry, I can't access it right now. But you have stoichiometry worksheet 1 that you're going to practice these today on. Let me know if y'all have any questions on them. I think the equations are already there. You may have to balance them, but I don't think you actually have to write any of the equations today. But you all have a great day. Let me know if you have any questions. Bye.